everyone, this is Kalpana here. In this video, we're going to see a problem from partial differential equations. So let's get going. Problem: form partial differential equation from z equal to x into f of ax plus by plus g of ax plus by by eliminating the arbitrary functions f and g. We are given a relation and we are asked to form a partial differential equation from it by eliminating the arbitrary functions f and g. So let's see. Given z equal to x into f of ax plus by plus g of ax plus by. Consider as equation number 1. Now let's partially differentiate it with respect to x. Partially differentiating 1 with respect to x. Just apply dou by dou x on both sides of 1. We'll get dou by dou x of z equal to dou by dou x of x into f of ax plus by plus g of ax plus by, right? Fine. This gives us dou z by dou x equal to partial derivative of x into f of ax plus by. So here we are going to apply u v whole prime formula, which is u prime v plus v prime u, right? Fine. This gives us f of ax plus by into dou by dou x of x plus x into dou by dou x of f of ax plus by. Okay, plus partial derivative of g of ax plus by. See, you can do directly, okay? It's not necessary to write these two steps. You can just do directly. If you are really good at partial derivatives, just do directly. Fine. Since dou z by dou x equal to p, let's replace it by the notation p. We'll get p equal to f of ax plus by into partial derivative of x with respect to x is 1 plus x times partial derivative of f of ax plus by is f dash of ax plus by into its inner derivative dou by dou x of ax plus by, right? Plus partial derivative of g of ax plus by is g dash of ax plus by into inner derivative dou by dou x of ax plus by, and this gives us p equal to 1 into f of ax plus by is f of ax plus by plus x times partial f dash of ax plus by into a into partial derivative of x with respect to x is 1 plus partial derivative of by with respect to x is 0. Since we are partially differentiating with respect to x, so we'll treat y as constant, okay? Plus g dash of ax plus by into a times partial derivative of x with respect to x is 1 plus partial derivative of by with respect to x is 0. Right, this gives us p equal to f of ax plus by plus x times we have a into 1 a plus 0 a into x ax, so you'll get ax into f dash of ax plus by plus a into 1 a plus 0 a into g dash is a into g dash of ax plus by. Right, consider it as equation number 2. Now let's find equation involving q. So we'll just partially differentiate 1 with respect to y now. Now let's partially differentiate 1 with respect to y. Just apply dou by dou y on both sides of 1. Partially differentiating one with respect to y. We'll just apply dou by dou y on both sides of 1 now. We'll get dou by dou y of z equal to dou by dou y of x into f of ax plus by plus g of ax plus by, right? This gives us dou z by dou y equal to, here we are partially differentiating with respect to y, so we'll treat x as constant. Here this x becomes constant, so constant into partial derivative of f of ax plus by is f dash of ax plus by into its inner derivative, that is dou by dou y of ax plus by plus partial derivative of g of ax plus by with respect to y is g dash of ax plus by into its inner derivative dou partial derivative of ax plus by. Since we know that dou z by dou y equal to q, just replace dou z by dou y by the notation q, you'll get q equal to x times f dash of ax plus by into partial derivative of ax with respect to y is 0 plus b into partial derivative of y with respect to y is 1 plus g dash of ax plus by into partial derivative of ax with respect to y is 0 plus b into partial derivative of y with respect to y is 1. This gives us q equal to 0. B plus 1 is b, b plus 0 is b, b into x is b, x into f dash. B into 1 is b, b plus 0 is b, b into g dash is b, g dash. G dash is nothing but g dash of ax plus by. Right? Now consider as equation number, say, 3. We got equation involving q now. That is q equal to bx into f dash of ax plus by plus b into g dash of ax plus by. We are considering as, we are considering it as equation number 3. Now let's find equation involving r. We know that r is nothing but dou square z by dou x square, right? We can also write this as dou by dou x of dou z by dou x, right? Since dou z by dou x can be replaced by the notation p, so you'll get dou by dou x of p, which is nothing but dou p by dou x. Dou p by dou x is nothing but r. This is nothing but r, this is nothing but r, this is nothing but r, right? So what we'll do is we need to find the equation involving r. So we'll choose equation involving p. This is the equation involving p, right? Now let's partially differentiate it with respect to x so that we'll get the equation involving r. Okay. Now what we are going to do is we'll just partially differentiate equation 2 with respect to x. Now let's partially differentiate equation 2 with respect to x. Just apply dou by dou x on both sides of equation 2. We'll get dou by dou x of p equal to dou by dou x of f of ax plus by plus a into x into f dash of ax plus by plus a into g dash of ax plus by, right? This gives us dou p by dou x. You can write p or you can write dou z by dou x instead of p. Okay. I'll write dou z by dou x instead of p. What you'll get? Dou by dou x of p is itself r, or dou by dou x of dou z by dou x is also r. Okay. Fine. This gives us dou square z by. We'll get the same thing. No need to worry. You can write p also. Is equal to partial derivative of f of ax plus by is f dash of ax plus by into its inner derivative dou by dou x of ax plus by. Here we are partially differentiating with respect to x, so we'll treat y as constant. Okay, plus a into, now we have two functions, right? Let's use uv whole prime formula. You'll get dou by dou x of x into f dash of ax plus by plus x into partial derivative of f dash of ax plus by is f double dash of ax plus by into its inner derivative dou by dou x of ax plus by. Right, plus a into partial derivative of g dash of ax plus by is g double dash of ax plus by into its inner derivative, that is dou by dou x of ax plus by, right? Since we know that dou square z by dou x square can be replaced by the notation r, so we'll get r equal to, we have replaced it by r, we'll get r equal to f dash of ax plus by into partial derivative, here a is treated as constant, right? A into partial derivative of x with respect to x is 1 plus partial derivative of by with respect to x is 0 plus a times partial derivative of x with respect to x is 1 into f dash of ax plus by plus x into f double dash of ax plus by into partial derivative of a into partial derivative of x with respect to x is 1 plus partial derivative of by with respect to x is 0. Okay, plus a into g double dash of ax plus by into partial derivative of a into partial derivative of x with respect to x is 1 plus partial derivative of by with respect to x is 0. That uses r equal to a into 1 a plus 0 a into f dash is a f dash of ax plus by plus a times 1 into f dash is f dash is nothing but f dash of ax plus by, right? Plus a into 1 a plus 0 a into x ax into f double dash of ax plus by plus a into 1 a plus 0 a into a square g double dash of ax plus by. Now just simplified, you'll get r equal to a into f dash of ax plus by plus a into f dash of ax plus by plus a into a square x into f double dash of ax plus by plus a square to g double dash of ax plus by, right? And now consider it as equation number 4. Yeah, you have to notice one thing here. You have a f dash. You can write this as 2a f dash. So let r equal to 2a f dash. This gives us r equal to a f dash gives a f dash plus a f dash gives 2a f dash. F dash is nothing but f dash of ax plus by plus the remaining terms a square x f double dash of ax plus by plus a square g double dash of ax plus by. Now consider as equation number 4. So this equation involves r. Now we'll find equation involving t. You know that t is nothing but dou square z by dou y square, or we can write this as dou by dou y of dou z by dou y, since we know that dou z by dou y can be replaced by the notation q. So we'll get dou q by dou y. Dou q by dou y is nothing but t. Now, in order to find equation involving t, we'll use equation involving 2. So this is the equation involving q. Now let's partially differentiate equation 3 with respect to y, so that we'll get equation involving t. So instead of q, we can write dou z by dou y also, or you can write q directly. Okay. But now let's partially differentiate 3 with respect to y. Partially differentiating 3 with respect to y. Just apply dou by dou y on both sides of 3. Here we are partially differentiating with respect to y, so we'll treat x as constant. So this gives us dou square z by dou y square equal to, here we are partially differentiating with respect to y, so we'll treat x as constant, right? So we'll get bx, which is constant, into partial derivative of f dash is f double dash. Partial derivative of f dash with respect to y is f double dash of ax plus by into its inner derivative, that is dou by dou y of ax plus by plus b into partial derivative of g dash of ax plus by is g double dash of ax plus by into its inner derivative, that is dou by dou y of ax plus by, right? This gives us, here You can replace dou square z by dou y square using the notation t. We'll get t equal to bx into f double dash of ax plus by into partial derivative of ax with respect to y is 0 plus b into partial derivative of y with respect to y is 1 plus b g double dash of ax plus by into partial derivative of ax with respect to y is 0 plus b times partial derivative of y with respect to y is 1. This gives us t equal to b into 1 b plus 0 b into b square x f double dash. B into 1 b plus 0 b into b square into g double dash. Consider as equation number 5. We got equation involving t. Now observe all the equations and see whether you can find partial differential equation or not. See here in R you have f dash, f double dash, g double dash. Here you are having f double dash, g double dash. Okay. If you take b square common from these two terms, you will get t equal to b square times x into f double dash plus g double dash, right? So this x, f double dash and g double dash can be replaced by t by b square using 5. But what about f dash? We don't have the value for f dash here because in this equation you have f dash, g dash. So it's hard to find the value of f dash, right? Now what we'll do is we'll just find s also. S is nothing but equation involving s also. We know that s is nothing but dou square z by dou x dou y. We can write this in two ways, dou z by dou x, dou by dou x of dou z by dou y, or you can write the same thing as dou by dou y of dou z by dou x, right? We know that dou z by dou y can be replaced by the notation q. This gives us dou q by dou x, which is nothing but s. And also we know that dou z by dou x can be replaced by the notation p. So this gives us dou p by dou y, which is nothing but s. Either you can pick equation involving q or you can pick equation involving p, which gives us the equation involving s. Okay. If you want to apply this, equation involving q to find equation involving s, just consider equation involving u and partially differentiate it with respect to x so that you will get the equation involving s. Otherwise, you can use this equation involving p and partially differentiate it with respect to y to get equation involving s. You can use either this or this. I'm going to use this. I'll use equation involving q. So partially differentiating partially differentiating 3 with respect to x. Just apply dou by dou x on both sides of equation 3. This gives us dou square z by dou x dou y equal to b into, here you have x and f dash of ax plus by. Let's use uv whole dash formula. So we'll get b into partial derivative of x with respect to x, or you can just write this as constant, not constant, f dash of ax plus by into partial derivative of x with respect to x plus x into partial derivative of f dash of ax plus by is f double dash of ax plus by into its inner derivative, that is dou by dou x of, we'll write clearly, okay, plus x into partial derivative of f dash of ax plus by with respect to x is f double dash of ax plus by into its inner derivative, that is dou by dou x of ax plus by, right, plus b into partial derivative of g dash of ax plus by with respect to x is g double dash of ax plus by into its inner derivative, that is dou by dou x of ax plus by. This gives us, since we know that dou square z by dou x square can be replaced by the notation as, we'll get s equal to b times f dash of ax plus by into partial derivative of x with respect to x is 1 plus x into f double dash of ax plus by into a times partial derivative of x with respect to x is 1 plus partial derivative of by with respect to x is 0 plus b into g double dash of ax plus by into a times partial derivative of x with respect to x is 1 plus partial derivative of by with respect to x is 0. Right, this gives us s equal to b times f dash into 1 is f dash. F dash is nothing but f dash of ax plus by plus a into 1 a plus 0 a into x is ax into f double dash of ax plus by plus a into 1 a plus 0 a into b ab g double dash of ax plus by. Right, this gives us s equal to b into f dash of ax plus by plus ab x into f double dash of ax plus by plus ab into g double dash of ax plus by. Consider as equation number 6. Okay. Now, using equation 6, we can find the value of f dash. Okay, we'll see now. Fine. Now see this equation involving s. Okay, fine. Now consider equation 5. We have 5, that is t equal to b square x f double dash of ax plus by plus b square into g double dash of ax plus by, right? Or we can also write this as b square x into f double dash of ax plus by plus b square into g double dash of ax plus by equal to t. Right? Now let's take a b square common from these two terms. We'll get b square times x into f double dash of ax plus by plus g double dash of ax plus by equal to t. Now take this b square to RHS, you'll get x into f double dash of ax plus by plus g double dash of ax plus by equal to t by b square. Right? So we got this, the value of x f double dash plus g double dash equal to t by b square using equation 5. Okay, x f double dash of ax plus by plus g double dash of ax plus by equal to t by b square by 5. Fine. Now it's b square. Now we have equation 6, right? We have equation 6. That is s equal to b into f dash of ax plus by plus ab x into f double dash of ax plus by plus ab into g double dash of ax plus by, right? Now let's take, I'm writing the first term as it is. Let's take ab common from these two terms. We'll get ab times x into f double dash of ax plus by plus g double dash of ax plus by. Good. We know the value of it, right? Which is t by b square. Just apply it. Substitute the value of it. ab into t by b square, where one b gets cancelled and you'll get a by b into t. Fine. Now we have s equal to b into f dash of ax plus by plus at by b. right? What we are going to do is we'll just bring this term to LHS. We'll get s minus a by b into t equal to b into f dash of ax plus by. Now let's bring this b to LHS. We'll get 1 by b times s minus a by b into t equal to f dash of ax plus by. So we got the value of f dash of ax plus by. So f dash of ax plus by equal to 1 by b times s minus a by b into t, right? By equation 6 we have used 5 and 6. Now we have equation 4. Okay, we'll use this equation 4 and these two to find the partial differential equation, right? Now we have 4. From 4 r equal to 2 into f dash of ax plus by plus a square x f double dash of ax plus by plus a square g double dash of ax plus by, right? Just substitute the values of f of ax plus by, which is 1 by b into s minus a by b into t, plus take a square common from these two terms. We will get a square times x into f double dash of ax plus by plus g double dash of ax plus by. See, this can be replaced by t by b square, which we got using equation 5, right? Now we'll replace this by t by b square. This gives us 2 into a by b s minus a by b into t plus a square into x f double dash plus g double dash can be replaced by t by b square. This gives us 2 a by b into s minus 2 a by b into a by b is a square by b square into t plus a by a square t, a square into t by b square is a square by b square into t, right? 2 a square by b square into t plus a square by b square into t gives minus, here you're having minus 2 a square by b square t plus a square by b square t. Minus 2 plus 1 gives minus 1. So you'll get 2 a by b into s minus a square by b square into t. So we have r equal to this one, right? So you can take the LCM of b and b square from it and you can just simplify it, or you can just multiply both sides of the equation with this b square. Okay, we'll just multiply both sides of the equation with b square. You'll get b square of r equal to b square of 2 times a by b into s minus a square by b square into t, which gives us rb square or b square r equal to 2, 1b gets cancelled here, right? Let's write it. 2ab square by b into s minus b square a square by b square into t. Okay, this is equal to 1b gets cancelled, b square gets cancelled, and you'll get 2abs minus a square t. So you got b square r equal to 2abs minus a square t, right? Fine. Now let's bring these two terms to LHS. We'll get b square r minus 2abs plus a square t equal to 0, which is the required partial differential equation, or we can write this as b square into r is nothing but dou square z by dou x square minus 2ab into s is nothing but dou square z by dou x dou y plus a square into t is nothing but dou square z by dou y square equal to 0, which is the required partial differential equation. This completes the problem. Okay. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.